Hello, I'm Stefan. I'm working for the new product introduction team in Belgium in the Nokia lab doing mobile gateways. The Cloud Mobile Gateway demo is connected to the Redis database. This Redis database is what we call the shared data layer. The shared data layer is storing all the information which is captured by the Cloud Mobile Gateway, and instead of keeping the information inside the VMs, we are storing this information into the database. This allows us to do a multi-directional scaling, so we do a scale out and a scale in. Scaling out is easy because that's just adding a VM, but scaling in is more challenging because suppose there was state in the VM, if you do a scale in and there is information in the VM, we would lose that information. So that's why we are putting the information in an external database, and if the VM is deleted, other VMs can query the database to get the information. So we can do scale out, scale in, but we can also do scale up and scale down by creating smaller or newer VMs, smaller VMs, and then we delete the previous VM. We can also do in the same way VM motion. So we create the VM in a new server and we delete the old VM in the old server. So let's go through the details of the Cloud Mobile Gateway. It has 4 types of VMs. We have the OM VM, which is doing the management of all the VMs of the Cloud Mobile Gateway. Then we have the load balancer, who has the external connectivity and is receiving all the signaling and data load from the network and is distributing it over the control plane VM and the data plane VM. We do separation of control plane and data plane as well. So the control plane is handling all the signaling, so it is creating sessions and it is deleting sessions, it is performing the handovers and so on. And then the data plane VMs are carrying the data traffic. Initially in the demo I will start with one control plane VM which has some load. I will increase the load in the demo, which will trigger an auto scale out. Then the second control plane VM will be created, and then I will decrease the load again to trigger the scale in again, and then the second control plane VM will be deleted. This Cloud Mobile Gateway has been instantiated by Cloudband. So Cloudband 3.1 is being used in this demo setup, which is using Red Hat OpenStack Kilo version. The VMs are running on Nokia Airframe servers. So here you see the 4 VMs. We have the load balancer VM, the data plane VM, the control plane VM, and here the OM VM. So currently only one control plane VM because the scale out is not yet done. I'm using Landslide to create sessions and to delete sessions and to perform handovers. So this is the Landslide where I create the sessions. So currently it has established 32,000 sessions and is performing 500 handovers per second. So here the black line is indicating that there are 500 actions going on. So that's all signaling load being processed by the control plane VM. These 32,000 sessions are put in the database. Here we see the database, and if we check the size of the database, we see our 32,000 sessions. This is the Cloud Mobile Gateway, and I will check the counters towards the cloud database connection on the first control plane VM. So here we see the number of transactions which control plane VM is doing towards the database, and we see here that is doing 500 transactions per second. For every handover it is each doing a write action into the database to store the new information in the database. So this control plane VM is lightly loaded, it has some load but not much. So this is OpenStack Ceilometer. Here we can see the CPU utilization of the control plane VM. So here we see that the control plane VM has a CPU utilization of 19%. So that's not that high, and we have configured 2 alarms. So the first alarm that we have configured is a low threshold alarm. So it's a low threshold alarm which is only raised when the CPU utilization is 18% for a duration of 1 minute. And then there is a high threshold alarm which is generated when the CPU utilization is above 37% for a duration of 1 minute. So currently none of these alarms are generated, which means that the CPU utilization is between 18 and 37%. And indeed here we have seen that the CPU utilization was 19%. So I will increase the load now. I will generate some extra sessions by using Landslide. So here I'm back at Landslide and I will establish a extra sessions, and these sessions are continuously doing attach and detach. So you see that the load is increasing now, and all this load is now going to the first control plane VM because the scale out did not happen yet. So if I go back to my CPU utilization, it should go up. So OpenStack Accelerometer is pulling the CPU utilization every minute. So currently we are still at 19%, but it will increase. If I check my Cloud Mobile Gateway, I will see that the number of transactions has been increased. So we are now here at more than 3000 write actions per second towards the database. So now we see that the alarm is generated, and then OpenStack will pick up that alarm and do the scale out. So if we now go to Cloudband, so I'm back here at Cloudband. So before we had one control plane VM, I do a refresh of the page, and I see that now an extra VM has been added. So that means that a new control plane VM has been added to the Cloud Mobile Gateway. So let's now verify the load of these two control plane VMs. So now we see that the control plane VM number 1 still has write actions to be done, and also the fourth. So the scale out has happened, so let's now look to the load on each of the two control plane VMs. So the first control plane VM has write actions to be done to the cloud database, so it is still load to be processed, but also the second control plane VM has been added to the Cloud Mobile Gateway and is also taking over some load from the first control plane VM. So now the second control plane VM will get all the attach and detach requests from the first control plane VM and will write all the actions in the database. So all the transactions, the control plane VM put them in the flush queue. So the flush queue contains all the write actions. We do not send the write actions immediately to the cloud database because we want to optimize the communication towards this database. If there are two requests for the same subscriber in the period that the first transaction is still in the queue, then we aggregate these two transactions together, and then we only send one request to the cloud database. So if we now check the second control plane VM, we see now that it is doing a lot of actions towards the database. And if we look back to the first control plane VM, we see that it's back to the 500 transactions per second, so the original handover request that it is doing. The load balancer is doing some caching, so it tries to select always the same control plane VM for the same subscriber, because also the control plane VMs can have cached information of that particular subscriber. So now the Cloud Mobile Gateway is in a high load. It has done the scale out. So let's now stop the attach and detach requests, but we keep the handovers. So I now stop the attach and detach requests. So this means that the second control plane VM will lose all its load, and only the first control plane VM will have some load, which were the original handovers, which were there from the start of the demo. So we see here that the attach request has dropped to 0, and also there are still some detach requests ongoing, but also that will drop to 0, while the handovers, they are just continuing. Because now the attach and detach stopped, the second control plane VM has nothing to do anymore. So let's verify that. So we see that now the counters at the second control plane VM are at 0, so it has nothing more in the flush queue. So now the second control plane VM has a low load, and it can now be removed because there is no load anymore for that. Now doing a scale in is easy because this VM has no sessions. It would be straightforward. So let's add some extra sessions such that this VM has extra sessions. So I go back to Landslide and add 1000 sessions. So these 1000 sessions will be handled by the second control plane VM because the first control plane VM is still doing the handover, so that VM is still under some load. So here we see that the second control plane VM got the 1000 sessions, so now it has some state. The state is being written in the external database, and if I do a scale in, the first control plane VM will take over the state via that external database. So now we see that the second control plane VM is sending the information to the external database. So now we are at 0, so it means all the information is stored externally now. So this VM has now created some sessions, and we can further reduce the load below 18% such that an automatic scale-in will happen. So I go back to my tester. So now I stop also the handover requests. So here you see a small peak that were the 1000 sessions. Now I stop the handovers, which will also create the detaches for these subscribers. So also these sessions are gone, which means that the load will be very low now. So all sessions has been removed. Now I can check that also in the external database. So here I'm at the external database, and if I check the size, so originally I started with 32,000 sessions, but now I still have the 1000 sessions which were created by the second VM, by the second control plane VM. Because the load goes down, the second control plane VM will be removed by Cloud. So let's check the CPU utilization in OpenStack now, in Ceilometer. So we see that we had for a long time a rather high load, and now the CPU utilization is decreasing, so we are now at a little bit above 18%, but the alarm threshold was 18%, so we have to drop below 18%. So after 1 minute this will be the case. Okay, we see now that the CPU utilization has dropped below 18%. So this means that the alarm is generated by OpenStack Ceilometer. So here we see that the alarm is generated, and then OpenStack Cloud will pick this alarm up and will perform the scale-in. So this was what we had originally, the two control plane VMs. I will refresh that page. And then we see that one VM has been removed. So the second control plane VM has been deleted by Cloud. So if I go back to my Cloud MG, if I look to the statistics of the second control plane VM, then I see that I don't have any statistics anymore because the VM is not there anymore. And then the question is, where are my 1000 sessions that I originally established? They are still in the database. I query the database and I see I still have my 1000 sessions created by this second control plane VM. But now, who will now process the further messages of these 1000 sessions? Well, that will be done by the first control plane VM. So if I do now a detach of these 1000 sessions, so I go to Landslide again to do the detach, then we see in the database that the sessions are being deleted, and they are being deleted by the first control plane VM because that's the only VM which is still there. And that is the conclusion of my demo. So we store the information externally in the database in case then a VM is being killed by doing a scale-in or the server goes down, then other control plane VMs can take over the sessions from that VM that disappeared.